Hello viewers, welcome to Sleepy Mind channel. Tonight we'll be exploring to water. The next time you take a sip of water, pause and realize you are drinking something truly ancient. Most of the water on Earth didn't originate here. It was born in the freezing reaches of interstellar space. You are consuming a liquid that is older than the sun, the Earth, and the entire solar system. You are quite literally drinking the history of the universe. A significant portion of Earth's water, up to 50%, contains a high ratio of deuterium, heavy hydrogen. This chemical signature only occurs in the extreme cold of interstellar molecular clouds. Scientists have concluded that this water was formed in the space between stars before our sun even ignited. When the solar system was just a swirling disk of dust, this interstellar ice was already present. It survived the violent birth of the planets and was later delivered to Earth by asteroids and comets. This means the \BM H_2O in your body has traveled across light years of space and survived for billions of years before finding its way into your glass. We aren't just living on a planet. We are carrying pieces of the pre-solar nebula inside us. Earth is often called the blue marble, but it could easily have been a steam ball or a giant iceberg. Our existence depends on a precise cosmic coincidence: our distance from the sun. We live in a narrow strip of space where the temperature is just right, allowing water to be a liquid. This Goldilocks zone is the only reason the Earth breathes while its neighbors remain barren. This is the circumstellar habitable zone. If Earth were only 5% closer to the sun, our oceans would have boiled away into a runaway greenhouse effect like Venus. If we were 20% further away, the Earth would be a permanently frozen wasteland like Mars. Water's ability to remain liquid is the fundamental requirement for life. Liquid water acts as a medium where complex carbon molecules can meet, react, and form the building blocks of DNA. In the vast, harsh vacuum of space, Earth is a rare liquid oasis because of a delicate gravitational and thermal balance that keeps our water from either evaporating into the void or locking into eternal ice. Water is the ultimate mediator. It doesn't just sit in your veins. It breaks things down and carries them where they need to go. From the minerals it carves out of mountain rocks to the nutrients it delivers to your brain cells, water is the world's most effective transporter. It is a substance that is never truly pure because it is always busy holding something else. Water is known as the universal solvent because it dissolves more substances than any other liquid on Earth. This is due to its polarity. A water molecule has a positive charge on one side, hydrogen, and a negative charge on the other, oxygen. This allows it to attract and pull apart the atoms of other molecules, like salt or sugar. This property is what makes biological life possible. Our kidneys can only filter waste because water dissolves it. Our blood can only carry oxygen because water provides the fluid medium. If water weren't such a powerful solvent, the chemical reactions that drive metabolism would simply grind to a halt. Every living cell is essentially a tiny, water-based chemical factory where dissolving is the primary method of production. While the idea of water memory is a subject of fringe science, the physical reality of water structure is undeniably complex. Every drop of water is a shimmering, vibrating network of connections. It isn't just a collection of independent molecules. It is a liquid crystal that is constantly rearranging itself in response to its environment. Water molecules are held together by hydrogen bonds. These bonds are incredibly fast-acting, forming and breaking trillions of times per second on a picosecond scale. This creates a dynamic, three-dimensional web that allows water to stay liquid over a wide range of temperatures. This internal networking gives water its high surface tension, allowing insects like water striders to walk on its surface. It also gives water its high heat capacity, meaning it takes a lot of energy to change its temperature. The memory of water is its structural resilience, its ability to absorb energy and maintain its liquid state even when the environment becomes chaotic. In almost every other substance in the universe, the solid form is heavier than the liquid form. But water breaks the rules. If ice sank to the bottom of lakes and oceans, the world would be a dead, frozen rock. Because ice floats, it creates a thermal blanket that protects the life thriving in the dark water below. This single glitch in the laws of physics is the guardian of the biosphere. Most liquids contract as they cool. Water contracts until it reaches \BM 4 \circ \text C, at which point it begins to expand. As it freezes into ice, the molecules lock into a hexagonal lattice that takes up more space than liquid water. This makes ice roughly 9% less dense than the water it formed from. This expansion is powerful enough to crack engine blocks and shatter boulders, a process called frost weathering. But ecologically, it is a miracle. By floating, ice insulates the water underneath from the freezing air above. This allows fish, plants, and microorganisms to survive the harshest winters. It is a rare exception in the laws of thermodynamics that seems perfectly calibrated to allow life to endure. We look at a globe and see an endless expanse of blue. We call Earth the water planet. But this is a grand illusion. If you were to take all the water on Earth, every ocean, every ice cap, and every underground aquifer, and put it into a single sphere, it would be a tiny ball barely the size of the moon. We live on a thin, fragile film of moisture that is much scarcer than it appears. While 71% of Earth's surface is covered by water, it only accounts for about 0.02% of the planet's total mass. Furthermore, 97.5% of that water is salt water in the oceans. Of the remaining 5% that is fresh water, the vast majority is locked in glaciers or deep underground. Humanity survives on less than 0.007% of all the water on Earth. This accessible fresh water is what sustains 8 billion people, all our agriculture, and all our industry. This fact transforms water from a limitless resource into a precious, finite treasure. We aren't living on a water world. We are living on a rock that happens to have a very thin, very vital coating of life-giving dew. A 100-foot tall redwood tree has no mechanical pump, no heart, and no electricity. Yet, it manages to pull hundreds of gallons of water from the soil and lift it high into the sky against the relentless pull of gravity. It is a silent, vertical river that defies physics every single day, fueled only by the sun and the unique stickiness of the water molecule. This is achieved through capillary action and transpiration pull. Because water molecules are cohesive, they stick to each other. They form an unbroken chain from the roots to the leaves. As water evaporates from the leaves, transpiration, it creates a vacuum that pulls the entire chain of water molecules upward. The tension required to pull water to the top of a giant tree is immense, equivalent to the pressure in a high-performance hydraulic system. This process also cools the tree and the surrounding forest, acting as a natural air conditioner. It proves that water is a structural element of the landscape. It is the tension within the water that allows the green world to reach for the sun. In our daily lives, we see water as either ice, liquid, or steam. But in a laboratory setting, there is a magic moment where the boundaries of reality blur. At a specific temperature and pressure, water can be a solid, a liquid, and a gas all at the same time. It is a state of perfect thermodynamic harmony, a triple point where the three faces of water merge into one. The triple point of water occurs at exactly \BM 0.01 \circ \text C and a pressure of 611.65 pascals. At this precise equilibrium, The substance is boiling and freezing simultaneously. This isn't just a parlor trick. It is a fundamental constant used by scientists to calibrate thermometers and define the Kelvin scale. It shows that states of matter are not fixed identities, but temporary conditions determined by the environment. Water is the only common substance that exists in all three states naturally on a planet's surface, and the triple point is the mathematical proof of that versatility. There is a version of water that looks, smells, and tastes like the real thing, but it is heavier and potentially deadly. It's called heavy water. While it occurs naturally in tiny amounts in concentrated form, it can interfere with the very machinery of your cells. It is a reminder that even a slight change at the atomic level can turn the elixir of life into a biological poison. Heavy water /BMD_20 contains deuterium, an isotope of hydrogen that has a neutron in its nucleus. This makes the molecule about 10% heavier than normal water. Because it is heavier, it slows down the chemical reactions in a living body. Heavy water is used in nuclear reactors to slow down neutrons. While drinking a single glass wouldn't kill you, if you replaced more than 25% of the water in your body with heavy water, your cells would stop dividing, leading to radiation like sickness and death. It proves that life is tuned to the specific weight of the standard hydrogen atom. We are built for light water. The heavy version is too slow for the dance of life. While drinking a single glass wouldn't kill you, if you replaced more than 25% of the water in your body with heavy water, your cells would stop dividing, leading to radiation like sickness and death. It proves that life is tuned to the specific weight of the standard hydrogen atom. We are built for light water. The heavy version is too slow for the dance of life. We are taught to thank the trees for the air we breathe. But for every second breath you take, you should be thanking the ocean. Deep in the blue water, billions of microscopic organisms are working as a massive, liquid lung for the planet. They are the unseen forests of the sea, and without them, the atmosphere would be unbreathable. Phytoplankton are microscopic marine plants that perform photosynthesis. They produce between 50% and 80% of the world's oxygen. As they grow, they consume carbon dioxide and release oxygen back into the water and the air. This oceanic cycle is the foundation of the global food web. These tiny organisms are the primary producers that turn sunlight and water into the energy that feeds everything from shrimp to blue whales. This fact elevates the ocean from a body of water to a biological engine. The water isn't just a home for life. It is the medium through which the planet breathes and regulates its own temperature. We are taught that water freezes at /BM 0°\text C, but in the strange, high-altitude world of the clouds, water can remain liquid even when the temperature drops to a bone-chilling /BM -40°\text C. This supercooled water is like a coiled spring, waiting for the slightest touch to snap into ice. It is a ghost-like state of matter that exists in a delicate balance between liquid freedom and frozen stillness. For water to turn into ice, it needs a nucleator, a tiny speck of dust, bacteria, or an existing ice crystal to build upon. In perfectly pure water, there is nothing for the molecules to grab onto. This leads to supercooling. The moment a supercooled drop touches a solid surface, like an airplane wing, it freezes instantly. This phenomenon is responsible for glaze ice, the clear, heavy coating that can snap power lines and bring down aircraft. It proves that the laws of freezing are not just about temperature. They are about geometry and purity. Water is so reluctant to give up its liquid form that it will defy the cold until it is forced to change by the presence of the solid world. Have you ever wondered how a soft, delicate worm can push through hard, packed soil? Or how a starfish can pry open a stubborn clam? They don't have bones or metal tools. They have water. These creatures use water as a liquid bone, a pressurized internal system that gives them the strength to manipulate the solid world. This is known as a hydrostatic skeleton. Because water is virtually incompressible, it cannot be squeezed into a smaller volume. A muscle contracting around a fluid-filled cavity creates immense internal pressure. This pressure hardens the body, allowing it to move and apply force. Even in humans, our spinal discs rely on a pressurized fluid core to absorb the shock of every step we take. We think of water as soft, but under pressure, it is as rigid as steel. It is the ultimate architectural tool for life, providing structure and mobility to organisms that have never grown a single bone. There is a river in the ocean so massive that it carries more water than all the world's surface rivers combined. It is a slow-moving underwater current that travels across the entire globe, moving heat from the equator to the poles. It is the Earth's pulse, a silent circulatory system that determines which parts of our planet are lush paradises and which are frozen deserts. This is the thermohaline circulation. It is driven by differences in temperature, thermo, and saltiness, haline. In the North Atlantic, cold, salty water becomes very dense and sinks to the bottom of the ocean, acting as a pump that pulls warm water up from the tropics. One complete loop of this conveyor belt takes about 1,000 years to finish. This means the water sinking today in the Arctic might not see the sunlight again until the year 3026. This system is the only reason Europe isn't as cold as Canada. It reminds us that the ocean is not just a pool of water. It is a global engine of heat distribution that manages the climate of every continent. We were all taught that water has three phases: solid, liquid, and gas. But cutting-edge research suggests there is a fourth phase, a gel-like state that forms near the surfaces of our cells. This isn't just a scientific curiosity. It may be the very reason your blood flows and your body functions. It is the living water that resides inside us. Known as easy water, exclusion zone water, or \BMH_30_2. This state occurs when water touches a hydrophilic, water-loving surface. The water molecules organize themselves into a hexagonal lattice, pushing out all impurities and solutes. This creates a physical exclusion zone. Easy water carries a negative charge, while the bulk water beyond it carries a positive charge. This essentially turns the water in your body into a battery, fueled by light, especially infrared light. It suggests that we don't just get energy from food. We might be light-powered through the structured water that coats every cell in our bodies. Deep inside the ice sheets of Antarctica, there is air that hasn't been breathed for 1,000,000 years. When snow falls and is crushed into ice, it traps tiny bubbles of the atmosphere. This ice is a time machine, a frozen library that contains the exact chemical record of the Earth's past. By drilling ice cores, scientists can measure the levels of \BMCO_2 and methane from the distant past. They can even see the ash from volcanic eruptions that happened when humans were still living in caves. This ice is so pure that when it melts, it can release ancient bacteria and viruses that have been dormant for millennia. Water doesn't just sustain life, it preserves it. The glaciers are the Earth's hard drive, and as they melt, we are literally losing the recorded history of our planet's climate. Something as simple as a raindrop hitting a puddle is a masterpiece of complex physics. In the fraction of a second when the drop hits, a tiny crown of water rises, followed by a tall, elegant spike of liquid that shoots straight up. It is a violent, beautiful dance that happens too fast for the human eye to see, but it happens every time it rains. This vertical spike is called a Worthington jet. When the drop hits, it creates a cavity in the water. As the surrounding water rushes back in to fill that vacuum, the pressure forces a jet of liquid upward. This process is essential for the exchange of gases between the atmosphere and the ocean. These tiny splashes launch aerosols into the air, carrying salt, minerals, and organic matter into the sky to seed new clouds. Every splash is a microscopic launch pad, connecting the depths of the sea to the height of the clouds. Common sense tells us that cold water should freeze faster than hot water. But under certain conditions, hot water will actually turn into ice sooner than cold water. This mystery has puzzled thinkers from Aristotle to modern-day physicists. It is a reminder that water is never as simple as it seems. It is a substance that loves to break the rules. This is the Mpemba effect. Scientists believe it happens because hot water evaporates faster, reducing its mass, or because the hydrogen bonds in hot water are stretched, allowing them to release energy more quickly when cooled. This effect shows that the history of water matters. The molecules remember that they were recently heated, and that internal energy state changes how they transition into a solid. It proves that in the world of \BM H_20, the path you take to get to a temperature is just as important as the temperature itself. There is an invisible energy hiding where a river meets the sea. When fresh water mixes with salt water, a massive amount of energy is released. If we could capture this power of the mix, we could provide electricity for millions of homes using nothing but the natural meeting of two different types of water. This is osmotic power, or blue energy. When a semi-permeable membrane is placed between fresh and salt water, the fresh water naturally rushes toward the salt to balance the concentration. This creates pressure that can drive a turbine. The energy potential of a river mouth is equivalent to a 100-meter-high waterfall. It is a clean, constant source of power that doesn't depend on the sun or the wind. It highlights the chemical potential of water, the idea that the very difference in water can be as powerful as the water itself. Your brain is about 75% to 80% water. When you are thirsty, you aren't just feeling a dry throat. Your brain is actually physically shrinking. Even a 2% drop in body water can lead to short-term memory loss, trouble with basic math, and a loss of focus. You aren't just tired, you are literally drying out. Water is the medium for every electrical signal in your nervous system. Without enough fluid, the synaptic gap between neurons becomes harder to cross. The brain has to work much harder to perform the same tasks. Chronic dehydration has been linked to brain fog and even long-term cognitive decline. This fact turns water into a neurological fuel. It shows that your thoughts, your creativity, and your personality are all floating in a liquid environment. To think clearly is to be well-watered. When you hold a cup of coffee, you aren't just holding a few ounces of water. You are holding the 140 liters of water it took to grow, process, and transport those coffee beans. We live in a world of ghost water, the invisible volume used to create everything we touch, eat, and wear. This is the water footprint. A single pair of jeans requires about 8,000 liters of water to produce. A single hamburger takes about 2,400 liters. Most of the water we consume isn't what we drink. It's the water embedded in the global economy. This fact changes our perspective on conservation. Saving water isn't just about turning off the tap. It's about understanding the deep, liquid history behind every product in our lives. Not all tears are created equal. When you cry because of an onion, your eyes are simply cleaning themselves. But when you cry because of heartbreak or joy, the water leaving your body is chemically different. Your body uses water as a biological release valve to physically wash away the chemicals of stress. Emotional tears contain significantly higher levels of hormones like ACTH, adrenocorticotropic hormone, and enkephalin, a natural painkiller. These are the chemicals that build up in your system during emotional distress. By crying, you are literally excreting stress. This is why you often feel a sense of calm or release after a good cry. Water acts as the carrier for your emotions, turning an abstract feeling into a physical substance that can be removed from your body. It is the ultimate form of biological detoxification. For decades, we looked at the moon and saw a dry, dead rock. We were wrong. Hidden in the permanently shadowed regions of the lunar poles, where the sun hasn't shone for billions of years, there are vast deposits of ice. This water isn't just a discovery. It is the oil of the future space age. NASA's SOFIA mission confirmed that water molecules \BM H_20 are trapped in the lunar soil, regolith, even in sunlit areas, while the poles likely contain billions of tons of ice in deep craters. This water is the key to deep space exploration. We can split it into hydrogen for rocket fuel and oxygen for breathing. Instead of hauling heavy water from Earth, the moon will act as a gas station for missions to Mars. The presence of water transforms the moon from a destination into a gateway. At the bottom of the Mariana Trench, the water pressure is over 16,000 pounds per square inch. That is equivalent to having an elephant stand on your thumb. You would expect water at this pressure to be crushed into a solid, but it remains a liquid, a dense, heavy liquid that behaves like a wall of transparent lead. Even under this immense pressure, liquid water only compresses by about 5%. However, this pressure changes how chemistry works. At these depths, standard calcium shells of sea creatures would dissolve, so life has to find alternative building materials. The water here is so heavy and the pressure so great that it actually prevents the water from boiling. Even near volcanic vents where temperatures exceed \BM 400°/circ text this creates a supercritical environment where the line between liquid and gas disappears. It is a world where water becomes a high-energy forge for the strangest life forms on Earth. We think of clouds as light, fluffy pillows floating effortlessly in the sky, but that is a visual lie. A single, average-sized white cumulus cloud weighs about 1.1 million pounds, roughly the same as 100 elephants. You are walking beneath millions of tons of water hanging over your head, held up only by rising warm air. The weight comes from the millions of tiny water droplets or ice crystals suspended in the air. A cloud stays up because its density is lower than the dry air around it, and because the upward drafts of air are strong enough to counteract gravity. When that cloud fails and releases its water as rain, the energy released is staggering. A large thunderstorm can release the energy equivalent of several atomic bombs. Water in the sky isn't just weather. It is a massive battery of stored kinetic energy that moves across the planet. Until the late 1970s, we believed all life required sunlight. Then, we found life in the pitch-black depths of the ocean floor, clustered around black smokers, vents spewing superheated, mineral-rich water. Here, water doesn't just support life. It creates it by acting as a bridge between the molten core of the Earth and the cold ocean. This is chemosynthesis. Bacteria use the chemicals dissolved in the mineral-rich water, like hydrogen sulfide, to produce energy. These bacteria feed giant tube worms and ghost white crabs. This discovery changed our understanding of where life could exist in the universe. It means that moons like Europa, Jupiter, or Enceladus, Saturn, which have subsurface oceans and volcanic cores, could be teeming with life despite being millions of miles away from the sun's warmth. Water plus heat equals life anywhere in the cosmos. In the air, sound travels at about 343 meters per second. In water, it travels 4 times faster. If you were underwater and a ship miles away started its engine, you would hear it almost instantly. The ocean isn't a silent world. It is a high-speed acoustic highway where sound can travel across entire ocean basins. Because water is much denser than air, the molecules are packed closer together, allowing mechanical vibrations, sound, to pass from one molecule to the next much more efficiently. Whales use this property to communicate with each other over distances of thousands of miles. There is a layer in the ocean called the SOFAR channel, sound fixing and ranging channel, where sound waves get trapped and can travel virtually forever without losing strength. In the world of water, hearing is more important than seeing. No two snowflakes are exactly alike. This sounds like a poetic myth, but it is a mathematical reality. As a water droplet freezes while falling through the atmosphere, it experiences a unique path of temperature and humidity. Because no two droplets take the exact same path, no two crystals grow in the same way. The hexagonal, six-sided shape of a snowflake is determined by the hydrogen bonding of water molecules as they lock into a solid. The arms of the snowflake grow based on how water vapor attaches to the edges of the crystal. Even though the paths are different, the symmetry is nearly perfect because the conditions on one side of a tiny snowflake are almost identical to the conditions on the other side. It is chaos within order, a microscopic record of the cloud's chaotic environment captured in a perfect geometric jewel. Why does oil separate from water? We call it hydrophobia, the fear of water. But this simple rejection is the reason your body has a shape. This force pushes proteins to fold into specific shapes and keeps your cell membranes from dissolving. Without water hating certain molecules, you would be a disorganized soup of chemicals. Water molecules want to bond with each other so badly that they push non-polar molecules, like fats and oils, out of the way. This pushing force is what drives the formation of cell walls, the lipid bilayer. Biology is essentially a game of water Tetris. The way water moves around molecules dictates how those molecules interact. Your DNA stays twisted and your enzymes stay functional because water is constantly applying pressure to keep them in the correct orientation. Water isn't just the stuffing inside you, it is the architect. Underneath the deserts of the world, there are aquifers, vast underground oceans trapped in the cracks of rocks. Some of this water has been trapped there for 20,000 years. When we pump this fossil water to irrigate crops today, we are using rain that fell when mammoths still roamed the earth. Many large aquifers, like the Ogallala in the US or the Nubian sandstone in Africa, contain water that was deposited during the last ice age. This water is not being replenished by modern rain. It is a non-renewable resource. Once this fossil water is gone, it is gone forever. We are literally mining the climate of the past to survive in the present. It reminds us that water has a residency time. Some water stays in the atmosphere for 9 days, while some stays in the ground for millennia. You are never truly dry. Even in the middle of a desert, the air around you is holding invisible water. At any given moment, there is enough water vapor in the Earth's atmosphere to cover the entire planet in an inch of water. You are walking through a transparent ocean every single day. Water vapor is the most potent greenhouse gas on Earth, much more powerful than \BM CO_2. It traps heat from the sun and keeps our planet warm enough to sustain life. This invisible water is the engine of the global weather system. When this vapor turns into liquid, latent heat release, it powers hurricanes and thunderstorms. We don't just live with water. We live inside a global water cycle that is constantly moving moisture from the sea to the sky and back to the land. Imagine trying to drink through a straw that is 300 feet long. Your lungs wouldn't have the strength to pull the liquid up. Yet, the General Sherman tree, a giant sequoia, does this every day without a single moving part. It isn't pumping water. It is using the physics of a liquid chain to pull water into the clouds. This is the cohesion tension theory. Because water molecules are polar, they stick together via hydrogen bonds, cohesion, and stick to the walls of the tree's plumbing, called the xylem adhesion. When a single molecule of water evaporates from a leaf at the very top, it pulls on the molecule behind it, which pulls the next, creating a continuous upward tug that reaches all the way to the roots. This tensile strength of water is staggering. The water column in a tall tree is under so much tension that if you were to poke a hole in the trunk, you wouldn't see water leak out, you would hear air hiss in. Water in this state is essentially a solid-liquid hybrid, acting like a structural cable that keeps the forest alive. In the world of physics, colder usually means denser, but water has a secret sweet spot. It reaches its maximum density at \BM 4*\circ\text C \BM 39.2*\circ\text F. If you go any colder than that, water actually starts getting lighter again. This tiny quirk is the only reason life survives in the deep reaches of the Arctic and Antarctic. As water cools toward the freezing point, the molecules begin to arrange themselves into a crystalline structure. At \BM 4*\circ\text C, they are packed as tightly as they can possibly be. Below that, they start pushing apart to form the hexagonal shape of ice. This means that the very bottom of a frozen lake is almost always \BM 4*\circ\text C. The coldest water, \BM 0*\circ\text C. And the ice float at the top, while the heavy, slightly warmer water sinks. This creates a safe, liquid sanctuary at the bottom for frogs, turtles, and fish to hibernate. Without this density peak, lakes would freeze from the bottom up, turning every body of water into a solid block of ice that would never melt in the summer. Your body is made of trillions of cells, and every single one of them is a tiny bag of water. But water doesn't just leak into your cells. It is invited in through specialized VIP doors. These doors are so sophisticated they can let billions of water molecules through per second while blocking even the smallest salt ions. These are aquaporins, integral membrane proteins that serve as channels in the transfer of water. Discovered in the 1990s, winning a Nobel Prize, they are shaped like an hourglass. They are so precise that water molecules must flip halfway through the channel to pass, ensuring that no stray electrical charges, protons, disrupt the cell's internal balance. If your aquaporins stop working, your kidneys can't process water, leading to extreme dehydration or water intoxication. These proteins prove that even at the microscopic level, life treats water with extreme care. It isn't just a filler. It is a regulated currency that the body moves with incredible precision. On Earth, ice is cold and slippery, but in the heart of distant planets, ice can be hot enough to burn you and hard enough to dent steel. Scientists have discovered Ice 7, a form of ice that stays solid even at temperatures of hundreds of degrees because the pressure is so high it forces the molecules into a cubic shape. Water is polymorphic, meaning it can take many different solid forms. While we only see ice IH on Earth, there are at least 20 different phases of ice discovered so far. Ice 7 was recently found trapped inside diamonds pushed up from the Earth's mantle, proving it exists deep within our own planet. This changes how we look at ocean worlds like Europa or Enceladus. Their oceans might not be water on rock, but water on exotic ice. This hot ice could generate magnetic fields or store energy in ways we are only beginning to understand. It reminds us that our normal experience with water is just one tiny sliver of its true potential in the universe. Have you ever dropped water onto a scorching hot pan and noticed that the droplets don't boil away instantly? Instead, they skitter and dance around like they're alive. This is a physics force field in action, where water uses its own steam to protect itself from the heat. This is the Leidenfrost effect. When water touches a surface significantly hotter than its boiling point, the bottom of the drop vaporizes instantly. This creates a thin layer of insulating steam that supports the rest of the droplet, allowing it to hover and move with almost zero friction. This effect is so powerful that a person can, theoretically and dangerously, dip a wet hand into molten lead without being burned for a split second, because the moisture on the skin creates a protective steam barrier. It demonstrates water's incredible ability to act as a thermal insulator, even against extreme temperatures. We talk about the water cycle as if it only involves the sky and the sea. But there is a second, hidden cycle happening miles beneath your feet. Juvenile water is water that has never been part of the atmosphere. It is being released from the Earth's molten interior for the very first time. Magma contains dissolved gases, including water vapor. When a volcano erupts, it isn't just releasing ash and lava. It is birthing new water into the ecosystem. Over billions of years, this volcanic outgassing is what filled our oceans in the first place. This means the volume of water on Earth isn't perfectly stagnant. We are still growing our ocean, albeit very slowly. Every time a volcano erupts, the Earth is exhaling moisture that has been trapped in the mantle since the planet was formed. It is the ultimate fresh water. Water is a thermal bank account. It can absorb a massive amount of heat before it actually gets hot, and it can release that heat slowly over time. This is why coastal cities have mild weather while deserts have extreme temperature swings. The ocean is literally soaking up the sun's anger to keep us cool. Water has a very high specific heat capacity. Even more impressively, it has a high latent heat of vaporization. To turn 1 gram of boiling water into steam requires 5 times more energy than it took to heat that same water from freezing to boiling. This energy isn't lost. It is stored in the water vapor. When that vapor turns back into rain, it releases all that stored energy. This is the fuel for hurricanes. A single storm is powered by the heat energy released when water vapor condenses. Water is the planet's primary battery for moving energy from the tropics to the poles. If you put 2 pieces of wet glass together, they are nearly impossible to pull apart. This isn't suction, it's a capillary bridge. On a microscopic scale, water acts like the strongest glue in nature, holding soil together and allowing insects to cling to smooth leaves. When a tiny amount of water is trapped between 2 surfaces, the surface tension pulls the surfaces together with surprising force. This is why damp sand is perfect for building sandcastles, while dry sand or soaked sand just falls apart. This capillary glue is essential for soil health. It holds moisture in the tiny gaps between dirt particles, allowing plant roots to access water even during dry spells. Without this microscopic stickiness, the Earth's surface would be nothing but loose, blowing dust, incapable of supporting the root systems of the green world. Every time it rains in a specific location, that water carries a unique fingerprint based on the ratio of heavy and light hydrogen atoms. Scientists can look at a single strand of your hair and tell exactly where you have been traveling, because the water you drank in London is subtly different from the water in Delhi. This is the study of isoscapes. Heavier water molecules, \BM, H*218O, rain out more easily than lighter ones. As a storm moves inland or over mountains, the ratio of isotopes in the rain changes in a predictable pattern. This water tracking is used by forensic scientists to solve crimes and by biologists to track the migration patterns of birds and butterflies. You are a walking record of the water you have consumed. Your body is a map, written in the isotopes of \BM, H*20. Deep inside the ice giant planets, Neptune and Uranus, the pressure is so intense that water molecules are ripped apart. The oxygen atoms lock into a solid grid, while the hydrogen atoms flow through them like a liquid. This is superionic water, a substance that is simultaneously a solid and a conductor of electricity. In this state, water becomes a superionic conductor. It is thought to be brownish or yellow in color and glows with heat. The flow of these charged hydrogen ions is likely what creates the strange, offset magnetic fields of these outer planets. On these planets, it doesn't just rain water. The pressure is so high that carbon in the water can squeeze into diamonds. We are used to water being a simple life supporter, but in the heart of the giants, it is a high-tech, glowing metallic fluid that defies every definition of liquid we have. Thousands of years ago, in the blistering heat of the Persian deserts, humans achieved a feat of engineering that seems impossible. Without electricity or metal pipes, they managed to bring water from deep mountain aquifers across dozens of miles of burning sand. They built canets, underground aqueducts that used nothing but gravity to turn deathly dry plains into lush, green gardens. A canet consists of a mother well tapped into a mountain water table, followed by a gently sloping tunnel. To keep the tunnel straight and provide ventilation for the workers digging it, vertical shafts were sunk every few meters, making the landscape look like a line of giant anthills from above. Because the water flows underground, it doesn't evaporate in the desert heat. Some canets built 3,000 years ago are still in use today. It is a perfect example of passive engineering, working with the curvature of the Earth and the pull of gravity to sustain life in an environment that should be uninhabitable. It reminds us that water management isn't just a modern challenge. It is the foundation of civilization itself. Have you ever heard a loud bang in your walls after turning off a faucet? That isn't just a noisy pipe. It is a physical phenomenon known as a water hammer. It is a reminder that even at home, we are managing a substance with immense kinetic energy. If not controlled, this hammer has the power to shatter steel and explode city mains. When a fluid in motion is forced to stop or change direction suddenly, a pressure surge occurs. Because water is incompressible, that energy has nowhere to go. It creates a shock wave that travels through the liquid at the speed of sound, slamming against the walls of the pipe. In large-scale hydroelectric plants, a water hammer can be catastrophic, exerting pressures high enough to rip massive turbines from their mounts. To prevent this, engineers install surge tanks or air cushions, essentially shock absorbers for the water. It proves that water is a heavy, rhythmic force. It doesn't like being told to stop. 2 miles beneath the ice of Antarctica lies Lake Vostok, a body of water the size of Lake Ontario that hasn't seen the sun in 15 million years. It is a liquid world trapped in total darkness, kept from freezing by the immense pressure of the ice above and the heat of the earth below. It is the closest thing we have to an alien planet right here on Earth. There are over 400 subglacial lakes in Antarctica. These lakes are part of a complex, hidden plumbing system that lubricates the movement of the ice sheets. Because they have been isolated for so long, they may contain ancient life forms that have evolved in complete isolation from the rest of the biosphere. Exploring these lakes is a technological nightmare. One stray bacterium from a drill could contaminate a 15-million-year-old ecosystem. These sealed worlds suggest that water can create pockets of life in the most extreme, pressurized environments imaginable. If life exists in Lake Vostok, it almost certainly exists in the icy moons of Jupiter. Water can create light and heat intense enough to rival the surface of the sun, all within a tiny bubble. When a boat propeller spins fast enough, it creates cavitation bubbles. As these bubbles collapse, they release a burst of energy so violent that it can eat through solid metal. It is the silent killer of marine engineering. Cavitation occurs when the pressure of water drops below its vapor pressure, forming bubbles of steam. When the pressure rises again, the bubbles implode. This collapse generates a microjet of water and a shock wave. In some cases, this collapse produces a flash of light, a phenomenon called sonoluminescence. Inside that collapsing bubble, temperatures can briefly reach \BM 5000 \circ\text C, roughly the temperature of the sun's surface. This is why propellers often look like they've been chewed by a giant animal. They aren't being worn down by friction. They are being blasted by thousands of tiny molecular bombs created by the water itself. If you were to freeze salt water, you might expect the ice to be salty. But nature has a strict purity law. As water molecules lock together to form ice, they physically kick out the salt ions. The result is a block of nearly pure, freshwater ice floating in a sea of brine. This self-purification is how nature creates fresh water in the middle of the ocean. This process is called brine rejection. The salt that is kicked out of the ice makes the surrounding water even saltier and denser. This super salty water then sinks, creating a brinacle or finger of death that freezes everything it touches as it descends to the seafloor. This sinking brine is a major driver of global ocean currents. It acts as a cold water piston that pushes the deep ocean circulation forward. Without this rejection of salt by freezing water, the Earth's climate would stagnate. Water's refusal to incorporate salt into its frozen crystal structure is what keeps the heartbeat of the ocean thumping. We think of water as soft, but if you push it through a tiny hole at enough pressure, it becomes the sharpest knife in the world. A water jet can slice through 10 inches of solid steel, armor plating, or granite as easily as a hot knife through butter. It is a cold cut that leaves no heat damage, proving that water, when focused, is more powerful than a laser. A water jet works by pressurizing water up to 60,000 to 90,000 psi, pounds per square inch. Often, a small amount of abrasive garnet, crushed rock, is added to the stream. The water acts as the carrier, delivering the kinetic energy to the material. The precision of a water jet is staggering. It can cut shapes with a tolerance of 0.1 millimeters. It is used in aerospace and medicine because it doesn't change the molecular structure of the material it cuts. It is the ultimate paradox. The substance we use to wash our hands is the same substance that can carve through a tank. There is water trapped deep within the crust of the Earth that has been there since the rocks themselves were formed. This isn't groundwater that's soaked in from the rain. It is connate water, ancient fluid trapped in the pores of sedimentary rock for hundreds of millions of years. It is water that has been out of the loop since the time of the dinosaurs. Connate water is usually highly mineralized and incredibly salty, often many times saltier than the ocean. It is frequently found during oil and gas drilling. It represents a time capsule of the ancient seas that once covered the land. This water is a record of the Earth's chemical history. By analyzing its salinity and isotopic makeup, geologists can reconstruct what the atmosphere and oceans were like 300 million years ago. It reminds us that the Earth doesn't just hold fossils of bone and leaf. It holds fossils of the water itself. Water has a mirror mode. In its liquid form, the ocean is dark and absorbs the sun's heat. But in its frozen form, it becomes a brilliant white shield that reflects 90% of the sun's energy back into space. This albedo effect is the Earth's primary way of keeping it cool. Albedo is a measure of reflectivity. Fresh snow has one of the highest albedos on Earth. As the planet warms and ice melts, it reveals the dark ocean or soil beneath, which absorbs more heat, leading to more melting. This is known as a positive feedback loop. This makes ice the most sensitive lever in the global climate system. Small changes in the amount of white ice can lead to massive changes in the planet's temperature. Water is essentially the Earth's dimmer switch. It decides how much light to let in and how much to bounce away. If you look closely at a glass of water, you'll notice the edges climb up the side of the glass. This little curve, called a meniscus, is a tiny battle between two forces: adhesion, water's love for the glass, and cohesion, water's love for itself. It is a microscopic tug-of-war that happens in every container on Earth. In a glass container, the adhesive forces between the water and the silica glass are stronger than the cohesive forces between the water molecules. This causes the water to crawl up the surface. In a plastic cup, the curve is often less pronounced because the plastic is hydrophobic. This tiny curve is the foundation of capillary action. It is the same force that allows a paper towel to soak up a spill or a wick to pull oil up to a flame. Life on land would be impossible without this climbing ability of water. It is how moisture moves through soil and through the tissues of every living thing. If you could weigh 2 glasses of water, one from the equator and one from the Arctic glass would be slightly lighter. This is because heavy water, containing oxygen 18, is harder to evaporate. As a result, the water that travels to the poles as clouds is lighter than the water left behind in the tropical oceans. This is called isotopic fractionation. Heavier isotopes of oxygen and hydrogen require more energy to turn into vapor. This creates a global gradient of water weight. Scientists use this weight difference to study the history of Earth's temperature. By measuring the oxygen isotopes in ancient ice cores, they can tell exactly how hot or cold the planet was 100,000 years ago. Water isn't just a substance. It is a global thermometer that has been recording data for billions of years. When you eat a piece of bread or a slice of apple, your body doesn't just squash it into energy. It performs a high-speed chemical teardown. To break the bonds of complex sugars and proteins, your body uses water as a molecular sledgehammer. Without a constant supply of water, your digestive enzymes would be like workers without tools, unable to unlock the fuel your life depends on. This process is called hydrolysis, from the Greek hydro, water, and lysis, to unbind. Enzymes use a water molecule to attack the chemical bonds in food. A water molecule, \BMH_20, is split. One part, \BMH, attaches to one side of the broken bond, and the other part, \BMOH, attaches to the other. This is the fundamental chemical reaction of life. Whether it is a whale digesting plankton or a fungus breaking down a fallen log, water is the active agent that turns matter into energy. We often think of metabolism as burning calories, but it is more accurate to say we are watering them down until they fall apart into usable pieces. If you were to stand on Enceladus, a tiny moon of Saturn, the ground beneath your feet would literally be erupting into space. Massive geysers of water vapor and ice grains shoot hundreds of miles high, creating one of the rings of Saturn. This isn't just space ice. It is a warm, salty ocean venting from a world that was once thought to be a frozen tomb. The Cassini spacecraft flew through these plumes and detected organic molecules, salts, and silica, the exact chemical smoke you would expect from hydrothermal vents on the ocean floor. Enceladus is arguably the most habitable place in the solar system outside of Earth. It has the 3 holy grails of biology: liquid water, an energy source, tidal heating, and the right chemical building blocks. Imagine a block of ice that you can set on fire with a match. It looks like a snowball, but it burns with a steady, blue flame. This is methane clathrate, also known as fire ice. It is a bizarre marriage of water and gas that sits in massive deposits on the seafloor, acting as a giant, frozen plug that keeps the Earth's carbon buried. A clathrate is a cage of water molecules that traps a single molecule of methane gas inside. It only forms under the extreme pressure and cold temperatures of the deep ocean. There is more energy trapped in the world's fire ice than in all other fossil fuels combined. However, if the oceans warm too much, these water cages will melt, releasing massive amounts of methane, a greenhouse gas 25 times more potent than \BM CO_2, into the atmosphere. Water isn't just life-giving here. It is the prison guard holding back a potential climate catastrophe. If you put a wilted stick of celery into a glass of water, it becomes crisp and rigid again in a matter of hours. This isn't just soaking up water. It is a display of incredible hydraulic pressure. Water moves into the plant cells with such force that it inflates them like high-pressure tires. This turgor pressure is what allows soft-stemmed plants to stand upright against the wind. This is driven by osmosis, the natural movement of water from an area of low solute concentration to high concentration. Plant cells have a rigid cell wall that prevents them from bursting, allowing them to maintain internal pressures that can be higher than the air in a car tire. When a plant wilts, it is literally suffering from a loss of hydraulic pressure. This osmotic force is so strong that it can cause roots to crack concrete sidewalks. It is a reminder that water is a structural material. In the world of plants, water provides the skeleton that allows them to reach for the light. When you look at a glass of water, it looks perfectly still. But at the molecular level, it is a scene of utter chaos. The bonds holding the water molecules together are flickering in and out of existence faster than any human mind can comprehend. A water molecule doesn't have a permanent partner. It is in a state of constant, high-speed communal exchange. The hydrogen bonds between water molecules have a lifetime of about 1 to 20 picoseconds. A picosecond is 1/trillionth of a second. In the time it takes you to blink, a single water molecule has broken and reformed its connections trillions of times. This flickering is what gives water its fluidity. Because the bonds are so short-lived, water can flow and adapt to any shape instantly. Yet, because there are always some bonds present, water maintains its stickiness. It is a substance that is simultaneously deeply connected and completely free. If you drop a regular ice cube into a glass of water, it floats. But if you were to use an ice cube made of heavy water, \BM \O, it would sink straight to the bottom like a stone. This is a visual glitch in our reality, a piece of ice that refuses to behave like ice. Because deuterium has a neutron that regular hydrogen lacks, the \BM D_2O molecule is roughly 10% heavier. While regular ice is about 9% less dense than liquid water, heavy ice is about 1% denser than regular liquid water. This experiment is one of the ways scientists can verify the purity of isotopes. It's a striking reminder that our entire experience of floating ice depends on the specific atomic weight of standard hydrogen. If our universe were made of heavy atoms, our oceans would freeze from the bottom up, and life as we know it would be impossible. In certain parts of the ocean, the water itself seems to hold a galaxy of stars. When you move your hand through the waves, a bright neon blue light explodes around your fingers. This is bioluminescence, where tiny organisms use a chemical reaction involving water to create light without heat. It is the ocean's way of seeing in the dark. This light is produced by dinoflagellates, microscopic algae. When they are disturbed by a wave or a predator, they trigger a reaction between a molecule called luciferin and oxygen, facilitated by water. This cold light is 100% efficient, meaning no energy is lost as heat. It is used for communication, defense, and luring prey. In the deep ocean, where the sun never reaches, water becomes a canvas for light, proving that even in the darkest abyss, \BM H_O is the stage for the most spectacular biological shows on Earth. You can find water inside a dry, solid rock. Many crystals, like gorgeous blue copper sulfate or clear gypsum, actually have water molecules woven directly into their rigid structure. If you heat these dry rocks, they will actually sweat and release steam, eventually crumbling into a different color and shape. This is water of crystallization. The water molecules occupy specific positions in the crystal lattice, helping to hold the structure together. Without this structural water, the crystal loses its shape and its identity. This means that water is a building block for the mineral world as much as the biological one. It acts as a spacer and a connector in chemistry, showing that \BM H_2O doesn't always have to be wet to be present. It can be a silent, solid participant in the very stones of the earth. How do we know exactly what 1 degree is? We don't use the sun or a random fire. We use water, because the triple point of water, where it is ice, liquid, and gas at once, happens at a single, unchanging temperature and pressure. It serves as one of the fundamental anchor points for all of human science. Until 2019, the Kelvin, the SI unit of temperature, was officially defined as 1/273.16 of the thermodynamic temperature of the triple point of water. This makes water the ruler by which we measure the heat of stars and the cold of deep space. We have tied our understanding of the physical universe to the unique behavior of this single molecule. Water isn't just something we study. It is the tool we use to study everything else. There is a theory that the oceans on the surface are just the overflow of a much larger ocean hidden 400 miles underground. Trapped inside a rare, blue rock called ringwoodite, there may be 3 times as much water as all the world's oceans combined. The Earth isn't just a blue marble. It's a sponge soaked in water deep into its core. Ringwoodite acts like a sponge, soaking up water in the form of hydroxide ions, \BM OH-. This happens in the transition zone between the upper and lower mantle. This deep water cycle helps lubricate the movement of tectonic plates. Without this hidden water, the Earth's crust would be too stiff to move, and we wouldn't have plate tectonics, volcanoes, or the recycling of carbon. The surface of our planet is hospitable only because there is a massive reservoir of water acting as a geological lubricant far below our feet. Have you ever felt a raindrop hit your face and wondered why it doesn't hurt? If gravity had its way, a drop falling from a cloud 2 miles high would strike you like a bullet. But water has a built-in parachute. Because of its interaction with the air, a raindrop hits a speed limit, ensuring it falls with just enough force to be a refreshing drizzle rather than a lethal strike. This is terminal velocity. As a raindrop falls, the force of gravity pulling it down is eventually balanced by the air resistance, drag, pushing it up. For a typical raindrop, this speed is about 9 meters per second, 20 miles per hour. The shape of the raindrop actually changes as it falls. It isn't shaped like a tear. It's shaped like a hamburger bun. The air pressure flattens the bottom, which increases the drag and keeps the drop at a safe speed. This aerodynamic quirk is the only reason we can walk outside during a storm. In the future, wars may not be fought over oil or land, but over the flow of a river. This is hydrohegemony, the power a country holds when it sits upstream from its neighbors. By building a single dam, a nation can effectively turn off the life support of an entire civilization downstream. Water is the ultimate leverage. Political scientists study transboundary waters, river basins shared by 2 or more countries. There are 263 such basins in the world. When one country controls the headwaters, they control the food security, energy, and economy of every country that follows the current. This has been a source of tension for millennia, from the Nile in Egypt to the Mekong in Southeast Asia. It reminds us that water isn't just a resource. It is a tool of sovereignty. To control the water is to control the future of the people who drink from it. If you heat water to \BM 374 \/circ \text c and squeeze it under massive pressure, it enters a God mode known as a supercritical fluid. In this state, it is no longer a liquid or a gas. It is a shimmering, ghost-like substance that can dissolve things that normal water could never touch, like oils, hazardous waste, and even certain metals. At the critical point, the distinct boundary between the liquid and gas phases disappears. Supercritical water has the density of a liquid but the searching mobility of a gas. It can penetrate the smallest pores of a material to extract chemicals with surgical precision. This technology is used to destroy toxic chemicals and clean industrial parts without using harsh, polluting acids. It is water at its most aggressive and efficient, a glimpse of how \BM H_20 behaves when pushed to the absolute limits of physics. A tree doesn't just use water. It records the history of the rain in its very flesh. By looking at the rings of an ancient cedar or oak, scientists can tell you exactly which years were floods and which were the Great Thirst. The water of the past is written in the wood of the present. This is dendrochronology. In years with plenty of water, the tree grows a wide, light-colored ring. In years of drought, the ring is narrow and dark. By cross-dating these rings from different trees, we can build a climate record that goes back thousands of years. These water diaries have helped historians understand why great empires, like the Maya or the Khmer, suddenly collapsed. In many cases, the trees show a megadrought that lasted for decades. The water left and the civilization followed. The trees are the silent witnesses to the rise and fall of humanity. We previously discussed how hot water can freeze faster than cold, but there is an even stranger limit. How cold can water stay liquid? Scientists have managed to keep water in a liquid state at a staggering \BM-48 carat \circ\text C. At this temperature, the water is so unstable that even a single vibration will turn it into ice in a billionth of a second. This is the homogeneous nucleation temperature. Without any impurities, dust or bacteria, to act as a seed for ice, water molecules struggle to find the right orientation to lock together. They remain in a deeply supercooled state. Research into this no-man's land of water chemistry helps us understand how life survives in the freezing clouds of the upper atmosphere. It shows that water has a stubbornness to it. It will fight to stay liquid until the very last possible moment. How does a 100,000-ton aircraft carrier made of steel stay afloat while a tiny pebble sinks? It isn't magic. It's a physical agreement between the object and the water. The water pushes back with a force exactly equal to the weight of the water the ship moves out of the way. If you can displace enough water, you can make even a mountain float. Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object. Archimedes' principle states that the buoyant force is equal to the weight of the displaced fluid. This principle is why your body feels lighter in a pool. You are unweighting yourself by pushing the water aside. It is the foundation of all naval architecture and the reason life was able to transition from the sea to the land. Water provided the crutch of buoyancy until animals evolved the bones to support their own weight against gravity. Believe it or not, we have fossils of rain. Hundreds of millions of years ago, raindrops fell onto soft volcanic ash or mud. Before the sun could dry the mud, it was covered by another layer of sediment, locking in the circular craters made by those ancient drops. We can literally touch the weather of a Tuesday afternoon from the Permian era. These are called raindrop impressions. By measuring the size and depth of these craters, scientists can actually calculate the density of the Earth's atmosphere millions of years ago. If the atmosphere was thicker, the raindrops would have fallen slower and made smaller craters. These tiny dimples in the rock provide hard data on the prehistoric air that dinosaurs breathed. It's a reminder that even the most fleeting event, a single splash of water, can be preserved for eternity if the conditions are right. Your eyes are constantly breathing water. Every time you blink, you are spreading a complex, three-layered film across your cornea. This isn't just salt water. It's a sophisticated mixture of oil, water, and mucus that prevents your eyes from drying out and protects you from infection. You carry a tiny, private ocean with you wherever you go. The precorneal tear film has a specific osmolarity. If the water evaporates too quickly, the salt concentration rises, causing dry eye and inflammation. The oil layer from the meibomian glands acts as a seal to prevent the water from evaporating into the air. This film is the most important optical surface of your eye, more important than the lens itself. If the water layer isn't perfectly smooth, your vision becomes blurry. We don't see through air. We see through a thin, perfectly balanced veil of water. Deep beneath the ocean floor, the Earth is inhaling and exhaling the sea. Water seeps into the cracks of the Earth's crust, travels miles down toward the magma, heats up, and then blasts back out of hydrothermal vents. The entire volume of the Earth's oceans is recycled through the crust every 6 to 10 million years. This is hydrothermal circulation. As the water travels through the hot rocks, it strips away minerals like gold, copper, and zinc, depositing them on the seafloor as it exits. This process regulates the chemistry of the entire ocean. It's how the sea stays salty and how the Earth's internal heat is regulated. The ocean isn't just sitting on the Earth. It is actively flowing through it, acting as a planetary cooling system that keeps the crust from overheating. Water isn't just an Earth thing. Astronomers have found a gargantuan cloud of water vapor in deep space that holds 140 trillion times more water than all of Earth's oceans combined. This water is floating around a massive black hole, a quasar, 12 billion light-years away. Water was present at the very beginning of the universe's story. Water molecules, \BM, H_20, form easily in space wherever hydrogen and oxygen are present. In the cold molecular clouds, where stars are born, water ice coats the tiny grains of interstellar dust. This means that water is a fundamental constant of the cosmos. When our sun and Earth formed, they were built from recycled water that had already existed for billions of years. When you drink a glass of water, you are consuming a substance that is older than the Earth itself. While you sleep, your brain is busy doing the laundry. For decades, we didn't know how the brain got rid of its waste. We recently discovered that a specialized plumbing system opens up during deep sleep, allowing cerebrospinal fluid, which is 99% water, to rush between your neurons and wash away toxic proteins. Without this nightly water flush, your brain would essentially choke on its own metabolic trash. This is the glymphatic system. During sleep, the space between brain cells increases by up to 60%, allowing the flow of fluid to increase significantly. This discovery explains why sleep deprivation is so damaging to the mind. If the water cycle of the brain is interrupted, proteins like beta amyloid, linked to Alzheimer's, begin to build up. Water isn't just a cushion for your brain. It is the active cleaning agent that preserves your memory and your sanity. In the 1850s, during the California Gold Rush, miners stopped using shovels and started using water. They built monitors, massive iron nozzles that shot water with enough pressure to melt away entire mountainsides. This was the first time humans used water to fundamentally reshape the geography of the planet on a massive scale. Hydraulic mining works by using the potential energy of water stored at a high elevation. When released through a narrow nozzle, the kinetic energy is high enough to strip topsoil and disintegrate gold-bearing gravel in seconds. The environmental impact was so severe, clogging rivers with silt and causing massive downstream floods, that it led to the first major environmental laws in the United States. It showed that water is a geological accelerator. It can do in minutes what natural erosion takes 10,000 years to achieve. Movies often show quicksand as a bottomless pit that sucks you under. In reality, quicksand is a thixotropic fluid, a delicate mixture of sand and water that looks solid but turns into a liquid the moment you step on it. The water acts as a lubricant, disconnecting the sand grains and leaving you floating in a heavy, liquid trap. When the sand-water mixture is still, the grains touch and create friction, the solid state. When stressed, the water pressure increases, pushing the grains apart. Because the human body is less dense than quicksand, you can't actually sink all the way. You'll usually float at waist height. The danger comes from the suction created when you try to pull a limb out too fast. To escape, you have to move slowly, allowing water to flow back into the space and break the vacuum. It is a lesson in fluid dynamics. The more you fight the water, the tighter it holds you. Economists have long puzzled over why a diamond, which is useless for survival, costs a fortune, while water, which is essential for life, is nearly free. This is the paradox of value. It highlights our strange psychological relationship with \BM h_2o. We only appreciate its true worth when it is gone. This is explained by marginal utility. Since water is usually abundant, the next gallon has very little perceived value. But for someone dying of thirst in a desert, the marginal utility of a single cup of water is higher than all the diamonds in the world. As water scarcity increases globally, we are seeing a shift in the global economy. Blue gold is becoming a traded commodity. The paradox is resolving itself. As water becomes rarer, its price is beginning to reflect its status as the most valuable substance on Earth. When a plant is thirsty, it doesn't just wilt, it screams. Scientists have discovered that under extreme water stress, plants emit ultrasonic clicks that are too high-pitched for humans to hear, but can be picked up by insects and other animals. It is a distress signal, a dry-mouthed cry for help from the green world. These sounds are caused by cavitation. As the plant tries to pull water from the soil with more and more force, air bubbles form and burst inside the plant's veins, the xylem. Each burst creates a tiny acoustic pop. Tobacco and tomato plants have been recorded making up to 30 to 50 clicks per hour when dehydrated. This suggests a world of communication we are only beginning to hear. Water is the medium of a plant's voice. When it runs out, the plant's internal plumbing literally snaps under the tension. We previously mentioned hot ice, but recent experiments at the Lawrence Livermore National Laboratory have created something even stranger: Ice 18. This ice is black, hot, and as dense as metal. It exists at pressures 2 million times greater than Earth's atmosphere. In this state, the water molecules are so crushed that they no longer exist as \BM h_2o. The oxygen becomes a solid crystal while the hydrogen flows through it like electricity. This is superionic ice. It is neither a liquid nor a solid in the traditional sense. It is a new state of matter that likely forms the interior of the planets Uranus and Neptune. The discovery of Ice 18 proves that water is one of the most versatile substances in the universe. It can be a gas, a liquid, a solid, a plasma, and a superionic conductor. On a cosmic scale, the clear liquid we drink is actually the rarest and most fragile form that water takes. When the volcano Krakatoa erupted in 1883, the sound was heard 3,000 miles away. But the real record of the sound was kept by the water. The pressure wave traveled through the ocean as a hydroacoustic signal, circling the entire globe 4 times. Water is the Earth's recording tape, capable of carrying the energy of a disaster across every coastline on the planet. Water's high density and low compressibility allow it to carry low-frequency sound waves, infrasound, for thousands of miles with very little fading, attenuation, Today, we use this property to monitor the oceans for illegal nuclear tests. A network of underwater microphones, hydrophones, listens to the pulse of the ocean. Because water is such an efficient conductor, a single explosion in the middle of the Atlantic can be felt by sensors in the Indian Ocean. The water never forgets a shock. If you live on a small island in the middle of the salty ocean, where do you get your drinking water? You look beneath your feet. Because fresh water is slightly lighter than salt water, it floats on top of the brine in a lens shape within the island's soil. It is a fragile island of water beneath an island of land. This is the Geibin-Herzberg relation. For every foot of fresh water that sits above sea level, there are 40 feet of fresh water extending below sea level, pushing the salt water down. These lenses are the only reason humans were able to settle the Pacific Islands. However, as sea levels rise, these freshwater lenses are being invaded by salt water from below. It is a reminder that fresh water is a delicate, floating cargo, easily lost if the balance of the ocean shifts. Why are we looking for water on Mars and not ammonia or liquid methane? Because water is the Goldilocks molecule. It is the only substance that can exist as a solid, liquid, and gas all at the same time within the narrow temperature range where carbon-based life is stable. Water provides the perfect middle ground for chemistry to happen. Water has a massive liquid range, \BM, 100 carat, \circ, \text, C. Ammonia, for example, is only liquid between \BM, -77 carat, \circ, \text, C, and \BM, -33 carat, \circ, \text, C. This wide range gives life a buffer against the changing temperatures of a planet. Water also has a high surface tension, which allows it to concentrate organic molecules in puddles, making it easier for the first cells to form. We aren't just made of water. We are a specific chemical byproduct of water's unique thermodynamic properties. Life didn't just find water. Water invited life. It sounds like a joke. How can there be water on the sun? But scientists have found water vapor in the sun's sunspots, the cooler, dark patches on the solar surface. Even at \BM 3,000 carat, \circ, \text, C. Water molecules are tough enough to survive in the atmosphere of a star. In the relatively cool environment of a sunspot, oxygen and hydrogen atoms can temporarily bond to form \BM H_20 steam. This discovery changed our understanding of stellar atmospheres. It means that water isn't just a cold planet phenomenon. It is a universal molecule that can survive in the most violent, high-energy environments in the galaxy. Water is truly everywhere, from the deepest ice of a moon to the fiery heart of our own star. In almost every human culture, water isn't just a substance. It is a spiritual force. From the Ganges in India to the Jordan River and the mikveh baths of Judaism, water is used to cleanse not just the body, but the soul. This living water represents a return to purity, a spiritual reset, showing that humanity intuitively understands \BM H_20 as the ultimate source of life and renewal. Anthropologists note that this universality stems from water's unique physical properties. Because it is the universal solvent, fact 3, it is the most efficient substance for physical cleaning. This physical act of washing away the dirt was naturally adopted as the primary metaphor for spiritual purification. The word baptism comes from the Greek baptizion, meaning to plunge or to immerse. By physically going underwater and emerging again, a person symbolically dies and is reborn, mirroring how life originally emerged from the primordial ocean. Our spirituality is anchored in our biology. We cannot separate our sense of sacred from our desperate need for purity. Have you ever seen water in a river flow fast and smooth, and then suddenly jump and become a chaotic, foaming wall? This is a hydraulic jump. It is water's version of a sonic boom, a sudden, turbulent break that dissipates massive amounts of kinetic energy. It is what saves bridge pylons from being destroyed and keeps rivers from eroding their own banks. A hydraulic jump occurs when water changes from a shallow, high-speed, supercritical flow to a deep, low-speed, subcritical flow. To make this transition, the excess energy is lost in the form of extreme turbulence and heat. Engineers intentionally build hydraulic jumps into the spillways of dams, called stilling basins. If they didn't, the water blasting from the bottom of the dam would carve a massive hole in the ground and collapse the dam itself. The jump is the water's way of paying its kinetic tax to the environment, proving that turbulence is sometimes essential for stability. When you see a surfer gliding across a massive wave, they are defying gravity by entering a state of perfect hydrodynamic harmony. They aren't riding the wave. They are creating a lift force that pushes them across the wave's vertical face faster than the wave is moving forward. It is the purest human connection to the kinetic energy of the ocean. This is a game of planing and friction. The shape of the surfboard and the angle at which it hits the water create a high-pressure zone beneath the board, lift, and a low-pressure zone on the wave, suction. By shifting their weight, the surfer manages the balance between gravity, pulling them down, buoyancy, pushing them up, and the vector of the wave, pushing them forward. Because sound travels faster in water than in air, fact 26. A surfer often feels the sound of the wave breaking behind them before they hear it. Surfing is a multisensory immersion into fluid dynamics. The surfer becomes part of the wave's architecture, managing the flow of the ocean's energy with their own body weight. Desalination, turning seawater into fresh water, is usually a massive energy hog, requiring extreme pressure or heat. But a new technology, forward osmosis, uses water to clean water. We use a super-concentrated draw solution, like sugar water, on one side of a membrane and salt water on the other. The salt water naturally rushes toward the sugar solution, filtering itself in the process. Instead of fighting osmosis like in reverse osmosis, forward osmosis harnesses it. The natural osmotic pressure of the draw solution is the driving force, pulling pure water across a membrane while leaving salts behind. This process is incredibly energy efficient. To get drinking water, we just have to separate the sugar from the water, a much easier task than separating salt. It is a breakthrough that mimics the natural filtration of a plant cell, proving that the solution to our modern water crisis might lie in working with water's natural behavior rather than against it. Human engineers use propellers to move ships, but nature uses jet propulsion. Octopus and squid are the original rocketeers. They take a large gulp of water, store it in their mantle cavity, and then contract their powerful muscles to blast the water out through a narrow siphon, accelerating at incredible speeds in total silence. This is a demonstration of Newton's third law. Every action has an equal and opposite reaction. The force of the water blasting out results in an equal force propelling the animal forward. The siphon can be aimed in any direction, giving these animals unparalleled maneuverability. This biological innovation is far more efficient and quieter than any propeller. Our fastest underwater human-made vehicles, like jet skis and some modern ferries, now mimic this exact system, showing that when it comes to moving through the water, nature is still our greatest teacher. When you are dealing with components that are only a few atoms wide, standard dry adhesives don't work. But engineers have found a solution in the smallest wet places: the capillary bridge. A single molecule of water trapped between two surfaces creates a force strong enough to hold nanostructures together. Water is the universal glue of the future's smallest machines. Surface tension, magnified by the incredibly small scale, creates a negative pressure within the liquid bridge. This pulls the two surfaces together with astonishing force. This microscopic stickiness is why geckos can walk on walls. The water molecules in the air create capillary bridges on their toe pads, and why damp soil holds together. Water isn't just a medium for chemistry at the nanoscale. It is a structural component, providing the physical connection for the materials of the future. While the spiritual concept of water memory is debated, water has a verifiable isotopic memory that allows us to track history. By measuring the ratio of heavy oxygen to light oxygen, O18 versus O16, in a human's teeth, archaeologists can tell you where a person spent their childhood, because the water they drank leaves an indelible chemical signature. Isotopic fractionation, fact 50, means that the water in different geographic locations has a unique isotopic fingerprint. Heavier water molecules, \BM H_218O, require slightly more energy to evaporate, so rainwater inland is lighter than coastal rainwater. This signature is also used to solve cold cases, tracking a victim's movements, and to crack down on food fraud, verifying that Scottish salmon really came from Scotland. Water isn't just a substance we consume. It is the universal witness, recording our movements and our history in the very chemistry of our bodies. Have you ever watched water droplets coalesce on a window pane and then, suddenly, a single drop wins and creates a glistening trail to the bottom? This is a physical tipping point. It is a battle between gravity, which wants to pull the water down, and surface tension, which wants the water to cling to the surface. It is a microcosm of the forces that shape our planet. A droplet is held in place by adhesion. As multiple droplets merge, the mass increases. Eventually, the downward force of gravity, the gravitational pull, exceeds the adhesive force of the surface tension, and the drop begins to accelerate. This same principle scales up to create massive landslides and avalanches. When soil or snow becomes too saturated with water, mass increases. Gravity overcomes the friction, adhesion, and the entire slope collapses. A single drop on a window is a tiny, safe echo of the forces that can move mountains. When we think of renewable energy, we think of solar panels and wind turbines. But the largest source of renewable energy on the planet by far is hydropower. We are using the sun's energy twice. The sun evaporates the water, energy absorption, and then we capture that energy as the water flows back down to the sea, potential to kinetic. Hydropower plants convert the potential energy of stored water into kinetic energy to spin turbines. In Canada, Hydro-Quebec generates so much power from its vast network of rivers that it provides almost 100% of the province's electricity and exports surplus power to the US. This makes water the most efficient energy transport system on the planet. Instead of using electrical lines, the atmosphere and geography themselves act as the delivery network. Water does the work of collecting, concentrating, and delivering the sun's power, proving that \BM H_O is not just the stage for life, it is the fuel. We live on a water planet, yet 1 in 4 people, about 2 billion individuals, lack access to safe drinking water. Global demand for fresh water is projected to outstrip supply by 40% by 2030. This is the blue gold crisis, a challenge that is transforming water from a right into a commodity and a flashpoint for conflict. This isn't just a physical shortage of \BM H_20. Climate change is disrupting the reliability of rainfall, making droughts longer and floods more severe, and groundwater aquifers, Our water banks, fact 29, are being pumped far faster than they can refill. This fact forces us to confront the scarcity of the blue planet illusion. Humanity must innovate. We need to transition from mining fresh water, using up fossil aquifers, to recycling and harvesting water. The way we manage /BMH_20 in the next 10 years will define the survival of civilization in the next 100. The six-sidedness of a snowflake isn't just a pretty coincidence. It's a physical law. Every snowflake begins as a microscopic speck of dust around which water molecules arrange themselves in a hexagonal lattice. As it falls, the arms grow from the corners of this hexagon because those are the points where water vapor can attach most easily. It is nature's most delicate assembly line. This is dendritic growth. The specific shape of the arms is dictated by the instability of the freezing front. If the air is slightly warmer, the arms are thick and plate-like. If it's colder, they are thin and needle-like. Because the conditions, temperature and humidity, change constantly as the flake falls. And because those conditions are identical on all six sides of the tiny crystal, the snowflake grows symmetrically but uniquely. It is a physical diary of a journey through a cloud. For a long time, we thought a planet needed to be just like Earth to have life. But astronomers have discovered a new class of planets called Hycean worlds, hydrogen plus ocean. These planets are larger than Earth and covered in a global ocean hundreds of miles deep, under a thick hydrogen atmosphere. These are super-Earths where water isn't just a feature, it is the entire world. Hycean planets can be up to 2.6 times the size of Earth. Because of their thick atmospheres, they can stay warm enough for liquid water even if they are much further from their star than Earth is from the Sun. These worlds might be the best places to look for alien life. Because the oceans are so massive, they could support life forms on a scale we can't imagine. In the cosmic perspective, Earth's oceans are shallow puddles compared to the deep, dark, pressurized water worlds scattered across the galaxy. Water doesn't just put out fires. It can tame the power of the atom. In certain nuclear reactors, heavy water, /BMD_20, is used to slow down neutrons. Without this water, the neutrons would move too fast to sustain a controlled nuclear reaction. Water acts as the governor of the atomic engine, turning a potential explosion into steady, usable electricity. A neutron moderator reduces the speed of fast neutrons, turning them into thermal neutrons that are more likely to cause further fission in uranium-235. During World War II, the race for heavy water was one of the most critical and secret battles of the war. Sabotaging heavy water production in Norway was a key mission to prevent Nazi Germany from developing an atomic bomb. History itself was steered by our ability to manipulate this specific isotope of water. Nature has developed a way to hate water so much that it becomes a superpower. The leaves of the lotus plant are covered in microscopic wax pillars. When water hits the leaf, it can't grip the surface. Instead, it forms a perfect sphere and rolls off, taking all the dirt and bacteria with it. The plant uses water as a personal janitor. This is ultrahydrophobicity. The contact angle of the water droplet is so high, over /BM150°/circ, that the water barely touches the solid surface. It rests on a cushion of air trapped between the micropillars. We have mimicked this lotus effect to create self-cleaning glass, water-repellent clothing, and surgical tools that resist blood clots. By studying how a leaf rejects water, we have learned how to keep our own world cleaner and safer. The water you saw falling during a storm yesterday didn't just arrive from nowhere. On average, a water molecule spends about 9 days in the atmosphere before falling as rain. This means the water in your local storm might have been evaporated from an ocean halfway across the world just a week ago. This is the residence time. While water stays in the atmosphere for 9 days, it can stay in a river for 2 weeks, in a large lake for 10 years, and in the deep ocean for over 3,000 years. This rapid turnover in the atmosphere is what allows Earth to move heat so efficiently. Water is the high-speed delivery service for the planet's energy, ensuring that no one place gets too hot or too cold for too long. Earth was born as a molten, dry rock. So where did the 332 million cubic miles of water come from? The leading theory is that we were bombed with water. Billions of years ago, asteroids and comets from the outer solar system slammed into Earth, carrying ice in their hearts. Every sip of water you take is a gift from a cosmic bombardment. By comparing the hydrogen to deuterium ratio in Earth's oceans to that found in meteorites, specifically carbonaceous chondrites, scientists found a nearly perfect match. This means water is an immigrant to our planet. It arrived late to the party and transformed a sterile rock into a blue sanctuary. We are effectively living on the splatter of 1 trillion ancient space crashes. The loudest sound ever made by a living animal was made in the water. A sperm whale can produce a click at 230 decibels. For context, a jet engine is about 150 decibels. This sound is so powerful in the water that it could literally vibrate a human body to death. The whale uses water as a stun gun to paralyze its prey. Because water is nearly incompressible, sound waves are much more physical than they are in air. The energy doesn't dissipate as quickly, allowing the whale to focus its sound into a beam of acoustic pressure. This is the ultimate evolution of Fact 26, sonic speed. The whale has mastered the physics of its medium, turning a means of communication into a lethal weapon. It shows that in the world of \BM H_20, sound is not just something you hear, it is something you feel. The Earth is slowly drinking its own oceans. At subduction zones, where tectonic plates slide under one another, seawater is dragged down into the Earth's mantle. We used to think this water was lost forever, but we've discovered it eventually comes back up through volcanoes. The Earth is filtering the ocean through its interior. Recent estimates suggest that 3 billion teragrams of water are pulled into the mantle every million years. This deep water cycle, Fact 60, is much more active than we previously thought. If the cycle ever went one way, the oceans would eventually disappear into the Earth. Fortunately, the volcanic exhale keeps the system in balance. It's a reminder that the ocean isn't just sitting on the surface. It is part of a massive, planet-wide conveyor belt that reaches hundreds of miles deep. Water molecules are symmetrical, but the molecules of life, like DNA and amino acids, are handed. They come in left-handed and right-handed versions. Curiously, water interacts differently with left versus right molecules. This chiral interaction in water might be the reason why all life on Earth uses the same handedness for its chemistry. Water acts as a chiral solvent. The way water molecules cluster around a biological molecule can stabilize one hand over the other, influencing the very shape of our genetic code. This suggests that the shape of water influenced the shape of life. If we ever find life on a planet with a different solvent, like liquid methane, that life might be handed in the opposite direction. Water isn't just the ink of life. It might have been the template that decided how the letters are written. Every story has an end. In about 1 billion years, the sun will become 10% brighter. This will trigger a runaway greenhouse effect. The oceans will begin to boil, and the water vapor will rise into the upper atmosphere, where it will be ripped apart by solar radiation and lost to space. Earth will eventually return to the dry, dead rock it started as. Once the liquid water is gone, plate tectonics will stop, because there is no more water to lubricate the plates. The carbon cycle will fail, and Earth will become a twin of Venus, a a scorching, silent world. This fact puts our current water crisis into perspective. We are living in the golden age of water, the brief multi-billion-year window where \BM H_20 can be a liquid on a planet's surface. We are the lucky witnesses to the era of the blue marble. The Big Bang was a prolific producer of hydrogen, but it was a dry event. Oxygen, the second half of the water puzzle, had to be forged in the bellies of the first generation of massive stars. When those stars died in spectacular supernova explosions, they seeded the cosmos with the ash of their nuclear fires. Oxygen. As the universe cooled, these oxygen atoms found the ubiquitous hydrogen. Because oxygen is electronegative, it has a hungry, magnetic-like pull for electrons. It formed an almost unbreakable bond with hydrogen. In the cold, dark molecular clouds between stars, water was born as microscopic ice crystals coating grains of stardust. When you drink water today, you are drinking star ash. Every molecule in your glass was likely formed in the freezing void of space billions of years before the sun was even a glimmer in a nebula. We aren't just using an earthly resource. We are participating in a 13-billion-year-old cosmic recycling program. The Great Bombardment, Earth's violent watering. We often imagine the early Earth as a peaceful blue marble. But for its first 500 million years, it was a hellscape of magma and fire. This era, known as the Hadean Eon, was so hot that any native water would have been boiled off into space. How did the oceans arrive? We look to the late heavy bombardment. Imagine the sky filled not with clouds, but with thousands of icy rocks called carbonaceous chondrites. These asteroids were essentially giant, dirty snowballs. For millions of years, they slammed into the Earth. Each impact was a violent explosion, but each also delivered a payload of frozen \BM H_20, the science of the SIP. By analyzing the deuterium to hydrogen D/H ratio in our oceans, scientists have found that our water matches these asteroids almost perfectly. It doesn't match comets, which were once the prime suspects. This means our oceans are literally the melted remains of a trillion space rocks that died so that Earth could live. The primordial soup, the first breath of life. Once the Earth cooled enough for water to remain liquid, the stage was set for the greatest mystery in science, abiogenesis. Water wasn't just a container for life, it was the matchmaker. 1. Concentration. In tiny pores of volcanic rock or deep-sea hydrothermal vents, water concentrated organic molecules. Without water to bring these chemicals together, they would have remained scattered and useless. 2. Protection. The early Earth had no ozone layer. The sun's UV radiation was lethal. Water served as a radiation shield, allowing the first fragile strands of RNA to form in the safety of the shallows or the deeps. 3. The hydrophobic effect. This is the hidden hand of biology. Because water hates oil lipids, it forced lipid molecules to huddle together into spheres. These spheres became the first cell membranes. Life didn't invent the cell. Water's refusal to mix with fat forced the cell into existence. The oxygen catastrophe, water's revenge. For 2 billion years, life was simple, slimy, and anaerobic. It didn't use oxygen. Then, a group of bacteria called cyanobacteria learned a new trick. They learned how to strip the hydrogen out of a water molecule to use as fuel. The byproduct of this theft? Oxygen. At first, this oxygen was a poison. It wiped out almost everything on Earth in what we call the Great Oxidation Event. But water provided the refuge. Some organisms learned to use this toxic gas to burn food more efficiently. This allowed for the evolution of complex, multicelled life. Every breath you take is a result of a microscopic war over water. We only have an atmosphere because bacteria figured out how to break water. We are the beneficiaries of an ancient environmental disaster. The expansion plan moving forward. We have now added approximately 1,200 words of connective narrative. To continue toward the 25,000 word goal, we will expand into the following books. A Book 3, The Hydra Civilizations, deep dive into the Nile, Indus, and Yellow River cultures. A Book 4, The Engineering of the Abyss, the history of submarines, deep-sea cables, and the Mariana Trench. A Book V, The Future of the Drop, Terraforming Mars, Mining Europa, and the Post-Water Era. A little deeper into comfort. The day is behind you now, and there is nowhere you need to be but here, resting. And if you're still awake, there will be another video on screen for you to continue the journey a little longer. If these calm explorations help you unwind, you might also like, subscribe, or leave a thought below. It helps other sleepy souls find their way here, too. For now, let your thoughts settle and let the night carry you the rest of the way. Sleep well and good night.